Okay, this is the 3-5 homework for first period class. I just wanted to go over maybe some that I thought might give you problems. I'm not going to go over every single problem. Let's look at, let's say number 4. Since it's 4 terms, it can go straight into the box. 25s cubed minus 100 s squared. Then that would be negative s and 4. What do the first row have in common? Well, they have a 25s squared. 25s squared times s would give me s cubed. 25s squared times a negative 4 would give me negative 100s cubed. S times negative 1 would give me a negative s, and negative 1 times negative 4 gives me a 4. So I'm on the right track. So that gives me 25s squared minus 1 and s minus 4. I'm almost done, but I want to check, do I have the difference of 2 squares here? If I do, I can go again. 25 is definitely something squared, and 1 is definitely a perfect square. So that would give me 5s plus 1, 5s minus 1, and s minus 4. And you're done. Now I figured this one might give you some problems too, just because it's got a lot of letters. Maybe I'll need a bigger box. Alright, so we have 7ac squared, bc squared, negative 7ad squared, minus bd squared. The first row has c squared in common. That means I need a 7a here, and I need a b here. That would mean I need a negative d squared there. So I end up with c squared minus d squared, and then 7a plus b. Well, gosh, c squared minus d squared is definitely the difference of 2 squares. That would be c plus d, c minus d. And then we tack on the 7a plus 5. All right? The next one, it's an x to the 4th. But one thing we forgot to do is check for that common factor that they might all have. These all have an x. So when I factor that out, I get 3x cubed minus x squared minus 27x plus 9. Now, you can go straight to the box. (3x cubed minus x squared minus 27x plus 9). We have x squared in common. That means this needs a 3x. This means negative 1. And this needs a negative 9. So I'll have an x. I'll have x squared minus 9 and 3x minus 1. Ooh, but x squared minus 9 is the difference of 2 squares. So I get x plus 3x minus 3. The next one is a 5th. X to the 5th. And we just do the same thing. We look for a common factor. Nope, no common factor there. So we got x to the 5th minus x cubed, 8x squared, and negative 8. These have an x cubed in common, so this needs an x squared, needs a negative 1, that needs an 8. Ooh, I have x cubed plus 8, and then I also have an x squared minus 1. I know this is the difference of 2 squares, but I have a feeling I know where that x cubed plus 8 comes from. That is the sum of cubes. So that would be when I would go find my helpful flowchart. Something cubed plus something else cubed. Well, I know that 8 is really 2 cubed. That's 2 cubed is 8. So in for the A is going to be x, and in for the B is going to be 2. So this part, I'm going to go ahead and draw a line. We're going to have x plus 2, and that's going to be x squared minus 2x, because a times b, plus 4, because that's b squared. And this other side is going to be x plus 1 and x minus 1. And that's it. So you always want to see if you can find that as well. Let's go ahead and skip over to number 9. Look for anything in common. Well, 3 of them have 2's, but not everybody, so we can't take that out. I've got 2z to the 5th, z to the 4th, minus 3 2z minus 16. What do those two have in common? They have a z to the 4th. So that means this needs a 2z to get there. This needs a 1. 2z times negative 16 would get me to negative 32z. And negative 16 times 1 does give me negative 16. So my factors are z to the 4th minus 16 and 2z plus 1. To the 4th? 16 is a perfect square. I wonder if this works. Could this be z squared plus 4 and z squared minus 4? Let's double check. Z squared times z squared gives me z to the 4th. The middle terms are going to cancel out. 4 times negative 4 is negative 16. It does work. Can we go again? Well, this is definitely the difference of two squares, but this one is the sum. So we can't do anything with that. But we sure can factor z squared plus 4. I get z plus 2, z minus 2. Yeah, last but not least. X cubed, 3x squared, 3x and 1. These two have x squared in common. X squared times x gives me x cubed. X squared times 3 gives me 3x squared. X times 3 gives me 3x. Does 3 times 3 give me 1? No. That means this does not factor. Or at least doesn't factor in the way we've been doing. So as far as we know, we can't do anything with it right now. And you're done.